Good morning, everyone. Today I'm going to talk about how to optimize performance in a React application. Optimizing application performance is key for developers who are mindful of keeping a user's experience positive to keep them on a app and engaged. In React applications, we are guaranteed a very fast UI by default. However, as an application grows, developers may encounter some performance issues. Therefore, today we will discuss some important ways to optimize the performance of a React app. Let's start with our agenda. So I'm going to discuss about profiling the React app, keeping component state local, memoizing React components, code splitting, windowing or virtualization, React fragments to avoid extra tags, and also lazy loading images. First, I'm going to discuss about profiling the React app. React allows us to measure the performance of our apps using profiling the React Dev tools. There we can gather performance information every time our application renders. Profiler records how long it takes a component to render, why components rendering, and more. From there, we can investigate the affected component and provide the necessary optimization. To use the profiler, we must install the React Dev tools for browser of choice. Now we should open Chrome DevTools to see the profiler tab when working on a React project. So here we have an app component holding a state and a child component. If we profile this application, we see the following behavior. The DevTools profiler highlights every rendered component while the input text field updates, and we receive every detail from the rendered components. Here we have the flame charts. In the flame chart, you can see how long it took to render the components and why that component is rendering. Likewise, the image below shows the child component is rendering because the parent component rendered. This can impact the React app's performance if we have an operation in a child component that takes time to compute. This brings to us our first optimization technique, that is keeping component state local. We learned that a state update in a parent component re-renders the parent and its child components. So to ensure rendering component only happens when necessary, we can extract the part of code that cares about the component state, making it local to the part of the code. So this ensures that only the component that cares about that state renders. In our code, only the input field cares about the state. So we extracted the state and the input to form input component, making it sibling to the child component. This means when the state changes in the form input component, that component renders. You can see that if you look at this GIF, the child component is no longer re-render on every keystroke. It only renders at an initial render. With this technique, we can greatly improve the performance of our React app, but sometimes we cannot avoid having a state in a global component while passing it down to child component as a prop. In this case, let's learn how to avoid re-rendering the unaffected child components. That brings us to the memoizing. Memoizing is an optimization strategy that caches a component rendered operation, saves the result in memory, and returns the cached results for the same input. In essence, if child component receives a prop, a memoized component shallowly compares the prop by default and skips re-rendering the child component. The prop hasn't changed. In this app, we have two states, and the child component, it uses the count state. So by updating the input field, both the app component and child component re-renders, which you can see in this GIF. Instead, the child component should only re-render when clicking the count button, because it must update the UI. Here we can memorize the child component to optimize our app's performance. For that, we can use React.memo. React.memo is a higher order component used to wrap a purely functional component to prevent re-rendering if the prop received in that component never changes. In here, the child component is wrapped using React.memo. So if the count prop never changes, React will keep rendering the child component and reuse the previous rendered result. You can see that result in this GIF. Now the child component not rendering when typing in the input field. So React.memo works pretty well when we pass down primitive values such as a number in our example. On the other hand, non-primitive values like objects, which includes arrays and functions, always return false between re-renders because they point to different space in memory. So the memorize component always re-renders. Here we are passing down the increment function to the child component. When the app component re-renders, even when the count button is not clicked, function redefines, making the child component also re-render. So to prevent the function from always redefining, we will use a use callback hook that returns the memorized version of the callback between renders. Take a look at the following code and the GIF. With use callback hook, increment count function redefines and child component rendered only when the count dependency array changes. So let's move to the next optimization technique, that is useMemo hook. When the props we pass down to child component is an array object, we can use the useMemo hook to memorize the value between renders. You can also use the useMemo hook to avoid recomputing the same expensive value in a component. It allows us to memorize these values and only recompute them if the dependencies change. Let's see how to apply the useMemo hook to improve React app's performance. Take a look at the following code that we intentionally delay to be very slow, and as we can see in this GIF, we experience a lag in our application whenever we try to enter text in the input field when the count button is clicked. This is because every time the app component renders, it invokes the expensive function and slow down the app. The expensive function should only be called when the count button is clicked, not when we type in the input field. We can memorize the return value of the expensive function using the useMemo hook so that it only recomputes the function only when needed, that is when the count button is clicked. For that we will have something like this. Now if we test that once again, we will no longer experience the lag while typing in the input field. The next optimization technique, that is code splitting. By default, when a React application renders in a browser, a bundle file containing the entire application code load serves to the user at once. This file generates by merging all the code files needed to make a web application work. However, as an application grows, size of the files increases, which increases the package size as well. At a certain point, this continuous file increases through the initial page load, reducing the user's satisfaction. With code splitting, React allows us to split large bundle file into multiple chunks using dynamic import, followed by lazy loading these chunks on demand using the React Lazy. The strategy improves the page performance of complex React applications. To implement code splitting, we transform our normal React imports like this and then to something like this. This syntax tells React to load each component dynamically. So after the import, we must render the lazy components inside the suspense component like this. The suspense allows us to display a loading text or indicator as a fallback while React waits to render the lazy components in the UI. Here we can see how text displays as fallback. So that's about code splitting. Next we have React fragments to avoid extra tags. Using fragments, reduce the number of extra tags that are included only to fulfill the requirement of having a common parent in the React component. In the case where a user is creating a new component, each component should have a single parent tag. Two tags cannot reside at the parent level, so we need to have a common tag on the top. To cater to this requirement, we often add an extra tag on the top of the component. See this code example. In the component, we need to have an extra tag to have a common parent for the component to render. This extra div does not have any purposes besides acting as a parent tag for the component. So it is added only because the component cannot have two parent tags. Therefore, just as a formality, we need to have an extra tag that encapsulates the tags that lie at the same level. To resolve the problem, we can enclose the elements inside a fragment. The fragment does not reduce any extra tag or tag to the component, but still provides the parent to the two tags so that the condition of having a single parent at the top level of the component is satisfied. In this code, there is no extra tag to enclose the tag, and here we have the fragments. Therefore, it saves effort for the renderer to render the additional elements on the page. So another way to optimize the React app is windowing or list virtualization. Imagine we have an application where we render several rows of items on a page. Whether or not any of the items display in the browser viewport, they render in the DOM affect the performance of our application. With the concept of windowing, we can render to the DOM only the visible portion of the user. Then when scrolling, the remaining list items render by replacing the items that exist the viewport. This technique can greatly improve the rendering performance of large lists. Both React Window and React Virtualized are two popular windowing libraries that can implement this concept. If you want to implement those, you can refer their documentations. So at last, we have lazy loading images. To optimize an application that consists of several images, we can avoid rendering all of the images at once to improve the page load time. With lazy loading, we can wait until each of the images is about to appear in the viewport before we render them in the DOM. Similar to the concept of windowing mentioned above, lazy loading images prevents the creation of unnecessary DOM nodes, boosting the performance of our React application. React lazy load image component are also popular libraries that can be used in React projects. So that's the concept behind lazy loading images. So that's how we can optimize performance in a React application. And there are also many more ways to optimize performance, and these are some of the important ones. So I hope these techniques will help you when you are working on a React project. So thank you everyone. Thank you for your participation.